مرحبا طلاب، إن شاء الله تكونون بخير. راح أبدي منه وجاي أعمل لكم هيك فيديوهات صغيرة، نظرا لأنه الإنترنت شوية صعب تحمل عليه فيديو طويل، وبالفاسيلتيز الموجودة عندي، وإن شاء الله خير. وبعدين نتواصل يعني أما على الإيميل أما نعمل جروب واتساب. أوكي. today راح أبدي بشابتر 5 بالكتاب اللي هو System Modeling، اللي هو بيحكي عن state variable modeling of systems. What's the meaning of state variable modeling? It's a way of modeling a system different from the classical method which we used to use, which is the transfer function. You remember from classical control that if we have a system with a transfer function g of s, with an input r of s and an output y of s, then we have y of s إلى r of s equal g of s. Then y of s equal to g of s times r of s. As you know, this is known. Okay, this is known, and this you decide on, like let's say like a step, for example. Then we get the output of the system by knowing this and knowing this. Then y of t, which is a time domain of ys, equal to the Laplace inverse of y of s. And as you know, this will give me a response. If it's a step, we call it a step response, something like that. مثلا, this is t, this is y of t. This response, if it's okay, then it's okay. But sometimes when systems are complicated, this response you may get it not correct, like it's not at the usual response which you used to. Why? You're not gonna know why. Why? Because it's only give the output. It doesn't give more details about the system. So for these reasons, they now go into using a state variable model. So we can say a better method is state variable method. Why? Because it gives me more details. It can give me a derivative of the output, second derivative of the output. So if there is something wrong with the system, if it's not in the output itself, then I know that something wrong with either the derivative or the second derivative. Then I know. So it gives me more details about the system. Now I can say y state variable is better. First, you know this method of transfer function, it's only suitable for linear system. If the system is linear, you can use transfer function. Otherwise, you cannot use transfer function. Then this method, which is state variable method, it is suitable for linear nonlinear, time varying, etc. The second thing is Sim-Sim in real life, which is more practical than the system which we are talking about here at the linear. Systems are more complicated. So sometimes systems are not only single input, single output. So this method may be used for single input, single output, and multi-input, multi-output system. Okay? Number 3. So we know from number 1, number 2, that a variety of systems can be modeled using this method, rather than this method, which is only suitable for simple linear system. Okay? The number 3, it's commonly used now because it's considered as modern method. Now, if you read any paper, you will find that this method, which is that one, is not really mentioned that much. But this method, which is the state variable, is really considered as the best method because you can use a lot of software on your computer, so you can simulate the system. It is modern as many software used. Okay? Now, state variable model is put as follows. X dot equal AX plus BU. This is equation 5.1 in the book, and the other is Y equal CX plus DU. Well, this is equation 5.2 in the book. Okay? These two equations are key equation. Okay? We're not gonna use a lot in through the course. Through this chapter, and then we have another chapter, which is chapter 8. It will deal with as well the state variable. This chapter deal with the state variable in the sense that you can implement it and get the response using MATLAB. So it is a MATLAB based part in this chapter. Chapter 8 will go more into detail and solving by hand. We'll get to that chapter later on. Okay? Now, A is an n by n, they call it system matrix. I hope this part is a bit easy for you. Maybe you have taken it in the control or in other subject. So if anything you need, we can text to each other, and you can ask anything you like. Okay? B is an n times R input matrix. This is the size of the system. That means if the system is a second order system from the differential equation, then this will be 2 by 2. This will be N, it is the order of the system, and R, number of inputs, okay, for N by R. Now, what's left? C. C is an M times N output matrix. Output matrix. What's left? D. D is an M times R direct transmission. What's the meaning of direct transmission? It's that it's directly related or connected between the input and the output we see later in the block diagram that we use to present the system. Okay, now we come to the what's the X, the U, and the Y. This is called system differential state variable equation, and this is called the Y is the output equation. Now the vectors X, U, and Y are X equal state vector. That is the vector which state we are talking about. We take that this is a state equation, where this is the derivative of the state. These are the states. Okay, that's X dot is the differential. X are the state like x1, x2, x3, and it is put as x1, x2, xn. Okay. U equal input vector. Input vector like U1, UR. That means we have R input, and we have Y equal output vector, and is put as Y1, Y2, Ym. This means that this system has R input and M output. It doesn't have to be equal. So you maybe have 4 input, 3 output, or the other way around. Okay, it doesn't have to be equal. Now, the state equation may be presented by the block diagram as shown below. Okay. When you have differential equation, you remember if you have first order differential equation, what do you get? What do you do to get the variable? For example, I have x dot. So what do you do to get the x? You make integration. Okay. If I have second order system, I make 2 integrators and so on. If I have third order system, I have 3 integrators and so on. So now we have integrator like that, dt, and then we have this is C, and we have a summer here, and we have y of t here. From here, I'll get, and now notice that I'm going to use a double line. I'll tell you why. This is A, of course this is like that, and we have something like this. We have, this is x dot of t, of course, and we have from A, we go like that. Okay, and we have here B, and we have something like that, and we'll go there, up there, and like that, and this is D. Notice that D is from the input here, U, to the output. So this is here U, like, and here the A matrix, and here you have a summer, of course, and here is the B, and from here we have D. From D we have to add it up to here, like that, better, and here is plus plus, and here we have y of t, and all the double line, you know, remember we used to make a block diagram, we put just a line, but here we have double lines. Why the double lines? Just to say that these are all vectors. When we have vectors, so we have put the double line, okay? We can see here the double line used in block diagram is to indicate that the signals are vectors quantities, okay, vector quantities.